In this video, we'll be looking at mapping and functions. Before I continue, I would like you to subscribe to this YouTube channel and do not forget to hit the notification bell to get updated for upcoming videos. I'll be starting with what we have there first, which is mapping. Let's say we are given two sets A and B. Given two sets A and B. Now, in mapping, we present sets this way. We use this picture to represent set. So let's say this is our set A and this is our set B. And set A has elements A, B, and C. Set B has elements E, F, and G. So a rule which assigns an element X in A, a unique element Y in B, is what we call mapping. What are we trying to say? From this diagram I'm giving here, if we map A to E or F, the rule that made us to assign F to A is what we call mapping. And the element we are assigning to a particular element in set A is a unique element. That means another element in set A. So that means A cannot map another element in B. That means we cannot have an arrow from A to E. Another thing I would like you to take note is what we call the domain and codomain. The starting point of a set or of a mapping is what we call the domain, while the end point is what we call the codomain. Now look at how I mapped A to F. You see that the arrow is starting from A and is ending at F. So the starting point, which is set A, is our domain. So this is domain. While the end point, which is B, is what we call the codomain. Now let's say B is mapped to G and C is mapped to E. There's what we call the image. I believe most of us must have been or stood in front of a mirror, and you all agree with me that when you stand in front of a mirror, an image must appear. It doesn't matter what's in front of that mirror. Whatever you place in front of the mirror was what will be captured in the mirror. Now this also applies here. What is mapped to A is what we call the image of A. A is mapped to F. That means the image of A is F. C is mapped to E. That means the image of E is C. Of C is E. And B is mapped to G. That means the image of B is G. So we can say the image of an element is what it is mapped to. In this case now, we can say F of A is equal to F and F of B is equal to G. If the rule which associates each element X in A unique element Y in B, is denoted by F, the mapping between the set A and the set B can be represented by any of the following notations. Okay? That is, we've already explained what mapping is and we called it a rule. Let's say we want to represent this rule with a letter F. We want to use letter F to represent this rule that is joining these two elements or these two sets together. Let's say other times it can be represented with letter G and letter H, but mostly and commonly it's usually represented with letter F. If you are to write the notations of mapping when it is represented by letter F, you can write it this way: A maps B, and we put our F up, just the way I did it here. Or the rule or is the mapping from A to B. So this is mapping notations. So whenever you see this notation, what should come to your mind is that this mapping or whatsoever we are giving is a rule that is joining an element in A to B because the arrow is starting from A to B. That's another thing to take note. Lastly, I want us to take note of what we call the range. When you hear range, we are talking about the elements in the codomain. Now our codomain is set B. What are the elements of set B? We have E, F and G. So E, F and G is what we call the elements or the range of the given set. So range is usually the element of the codomain, or we can say the image of the domain. Now let's move to the other term we have there, which is the functions. So let's now look at what we call function. A function is a mapping whose codomain is the set of numbers gotten or obtained by the rule assigned to the mapping. When we are dealing with function, there must be a rule given, and with that rule, use it to get the values of the codomain, and that's what we call functions. Now let's consider this mapping. X maps to Y, and this is the rule. So we can say that f of x maps to, let's say the rule we are giving is 2x plus 1. From here you agree with me that y is equal to 2x plus 1. Now let's say we are now giving values of x to be, let's say 2, 3, 4 and 6. From here we can get our values of y. All we need to do, we have to substitute the values of x in the given rule, which is the function. So when x is 2, because that's the first element, well, it doesn't mean you start from the first element. You can start from any of the elements of your choice, but you just take note of the values and the answer it's giving. When x is 2, we have our y to be 2 into 2 plus 1, which is give us 4 plus 1, which is 5. When x is 3, we have our y to be 2 into 3 plus 1, which is equal to 6 plus 1, which is 7. Also do for when x is 4, we have y into 2 into 4 plus 1, which is 8 plus 1, which will give us 9. Lastly, when x is 6, we have our y to be 2 into 6 plus 1, which will give us 12 plus 1, which is 13. From here we can now conclude that our y, the element of y is 5, 7, 9 and 13. So if we are to write this in function format, we will say f of 2. That means when you substitute 2 in f of x, which is y, it gave us 5. Then f of 3 gave us 7, f of 4 gave us 9, and f of 6 gave us 13. So this is how function is being written and represented. So now let's now move to what we call types of mapping. Yeah, mapping have types of mapping. The first type of mapping we'll be looking at is one-to-one mapping. In one-to-one mapping. Now when we're talking about one-to-one mapping, is when one element in the first set is mapped to one element in the second set. Let's say f of x, let's say f is mapped to y. Let's say f of x mapped to y is a mapping. Then f is called a one-to-one mapping if different elements in the domain maps or contains different elements in the codomain, which is the images. Now representing this, let's say we have set x and set y. 1, 2, 3. This is A, B, C. Now we have three different elements in set x and we have three different elements in set y. If each of these elements in x is mapped to different elements in y, we call it one-to-one mapping, as the name implies, one-to-one. That means you cannot see two elements in x being mapped to A in one-to-one mapping. Thus, we cannot classify it as a one-to-one mapping. A practical example is where we have each state having a governor. So, there is no state that can have two governors. So, we can say that is a one-to-one mapping, one-to-one. A student to his or her unique matriculation number or student ID. That's what one-to-one mapping. So we represent this by saying f of x1 is equal to f of x2, and this means x1 is equal to x2. The next type of mapping I would love us to look at is onto mapping. Just like I said, let f of x maps y be a mapping. So we say f is called an onto mapping if every element of the codomain is an image of at least one element in the domain. Now that means, okay, so let's have our x and y so that I can explain this better. X and y. So using like the first example, we have 1, 2, 3 and we have A, B, C. Here now, when an element in the codomain is mapped to at least one element, that means like A now, A is mapped to 1 and A is still mapped to 2. This is an onto mapping. A can also be mapped to as so many elements it wants to be mapped to. So this is what we classify as onto mapping. A practical example of onto mapping is the mapping that associates local government areas to each state. Yes. A state have more than one local government, like some even have more than 10 and so on and so forth. Another example is a mapping of faculties to a certain universities. A university cannot have a department or just one faculty. It must be more than one. So I hope people are getting a practical application of this. Now in summary of this too, let me also use like the instance I used earlier. I was standing in front of a mirror. A single object cannot stand in front of a mirror and you'll be seeing more than one image. If it is one object in front of the mirror, it will project one image. Just that's a practical example of one-to-one mapping. Then onto mapping, two objects can have one image. Most of us in sciences we did block prism, triangular prism, where we align the pins. We can align two pins and it will produce one image. So another example I can stand in front of a mirror and somebody I'm taller than can be at my back, but I will just be the one showing in front of that mirror. That's a single image. Though we are two objects in front of the mirror, we have one image. So that's a practical example of onto mapping. Do not forget to subscribe to this YouTube channel and hit the notification bell to get notified for upcoming videos. Thank you.